This series of training videos is brought to you by the Fox Canyon Groundwater Management Agency and the Irrigation Training and Research Center of Cal Poly State University San Luis Obispo in order to assist growers with a new Irrigation Allocation Index program. This video will address two irrigation performance terms: Irrigation Distribution Uniformity and Irrigation Efficiency. We will discuss a little bit about the definitions of these terms and some of the difficulties that they present, especially when it comes to calculating irrigation efficiency. This figure illustrates irrigation uniformity in simple terms. The top image shows a field being irrigated with poor uniformity. As you can see, too much water is being applied to one part of the field, and not enough to another part of the field. The bottom image shows a field where most of the water is being applied relatively uniformly, meaning all of the plants across the field are receiving approximately the same amount of water. Additionally, with good uniformity, there is no excess of water being applied. For all irrigation events, we would like to have good uniformity, although it is not possible to have perfect uniformity. The main advantage to distribution uniformity is that it is actually quite straightforward to measure and calculate. An irrigation evaluation team can go out into the field and collect data on depths of irrigation water applied. It usually takes less than half a day. Then, this equation can be used to compare the low quarter depths of water applied to the average of depths applied to the entire field to come up with a measurable DU value. Typical values are between 0.85 and 0.9 for a new system, but many systems have DU values below 0.5. When a field has a low DU value, it means the irrigator has to apply a lot more water in order to get enough water to the driest part of the field. This graph shows uniformity values of fields evaluated throughout California. As you can see, most of the values are above 0.8. The graph also brings up an interesting side note, as it compares the uniformities of drip irrigation and microspray. Although the microspray values are quite good, the drip systems clearly outperform the microspray, which causes people to ask if that means that drip is better. In terms of simple distribution uniformity, drip tends to perform better because drip tends to use pressure compensating emitters, which allow for very uniform water distribution out of the product. Additionally, drip uses more emitters per plant, and that tends to even things out more and improve the uniformity. However, there are many situations where drip is not appropriate. Sometimes growers use microspray to get larger coverage, to get better root zone development, or to spread out a water quality problem. Sprayers do tend to get a little bit of plastic abrasion due to sand wear, or other things going through the sprinkler, which wear out the sprinkler and affect the performance. In contrast to distribution uniformity, there is also the measure of irrigation efficiency. There are many ways to calculate efficiency, but the basic idea is that you're trying to get a measure of the water being beneficially used in the root zone compared to the water applied. It always has to be less than 100% and is always reported as a percentage value. This graphic shows the difference between an efficient irrigation event and one that is not efficient. Notice that in both images, the uniformity is actually quite good. There are no bare spots and the plants are all receiving approximately the same amount of water. But we're not talking about uniformity here, we're talking about efficiency. So in the top image, just enough water was applied to satisfy the irrigation requirements. In the bottom image, the irrigation was applied for too long, and this caused extra irrigation to go past the root zone. The goal of irrigation efficiency is to determine how to use just enough water to meet plant water needs, no more, no less. The problem is that the technical definition of irrigation efficiency is fairly complex, and most growers and water agencies don't have a good handle on what or how this calculation works. It's very difficult to come up with precise definitions of what is considered beneficial, and that makes the value difficult to calculate. For instance, do irrigators base the irrigation efficiency on ETO or ETC? How about the extra water that is used for uniformity or for salinity? Where does the effective rainfall come into the equation? All of these factors make the calculation of irrigation efficiency very complex, and a group of experts could sit down together, look over the same data for a region, and still not come up with a specific right answer for what the irrigation efficiency value should be. In many cases, different values could be reached based on whether a grower is basing their irrigation efficiency values on ETO or ETC. The difference between ETO and ETC is that the ETO centers on a reference crop. For most areas in California, grass is used as a reference. ETC, on the other hand, is the adjusted value based on the specific crop that is being evaluated. So you might have an ETO value from a reference grass crop that is 50 inches, but the ETC value for a tree crop may get graded down to 40 inches due to various coefficients, because that tree crop may require less water than the grass crop. This video has covered a very brief discussion about two key irrigation performance terms: distribution uniformity and irrigation efficiency. As mentioned, DU is primarily used by the irrigation industry because it is a value that can actually be reasonably calculated, whereas irrigation efficiency is more subjective and complicated to calculate. Therefore, for the Fox Canyon GMA, ITRC proposes not using IE, but rather an index value called the Irrigation Allocation Index, which will be described more fully in future video sequences. This concludes this video for the Fox Canyon Groundwater Management Agency's Irrigation Efficiency Program. Thank you for taking the time to go through the material. If you have any further questions, please contact the staff at the Fox Canyon Groundwater Management Agency.